In today's notes, we are going to look at analyzing graphs a little further than what we have so far. So when you're looking at a graph and you read the graph from left to right, you should be able to say if the graph is increasing, decreasing, or staying constant in each segment or section of the graph. So if your graph is increasing, then that part of the graph is going to appear to go uphill or upward. If the graph is decreasing, that part of the graph will appear to go downward. And then if the graph stays constant, that part of the graph will be horizontal or flat. So again, part of the key to this though is that you have to be reading the graph the right way, which means that you have to read it just like you read a book, which is left to right. So if we move down, we're going to look at these couple of examples that you see down here. So in example 1, we have this graph showing here. And what we're going to work to do is we're going to look at each segment of the graph and try to mark whether that segment is showing increasing, decreasing, or constant. So the first section that they want us to look at is the section from A to B. So we are looking at this section here. So as I look from left to right, this goes downhill, which means that that section of the graph would be decreasing. In the next section, between B and C, so from B to C, left to right on the coordinate plane, that goes upward. So when the graph goes upward, your graph is increasing. The next section that they want us to look at here is the section between C and D. So left to right, C to D. This is staying horizontal or flat. So from above, we know that when it says horizontal or flat, that section is constant. Which brings us to the last section that they ask us to look at, which is the section between D and E. So left to right, D to E, I go uphill or I move upward, which means that the graph is increasing in that segment. So you should be able to tell in any segment of the graph that we ask you about whether it is increasing, decreasing, or constant. So if we now move to this idea here, so a graph can reach a local maximum or local minimum value at a place where the graph changes direction. So where the graph goes from increasing to decreasing is where we are going to experience either a local maximum or a local minimum value. When you are looking at the graph, again from left to right, just like you read a book, and you reach the top of a hill, that is known as a local maximum. When you reach the bottom of a valley, so when it dips down and you're going downhill and then you change directions to go uphill, that is called a local minimum. So local maximums and local minimums we should be able to identify from the graph. So let's look at the graph that we see below. So here in example 2, you have a graph sketched on the coordinate plane, and we are being asked to use the graph of function h. So we don't know the function, but this is called function h, to locate all values at which h has a local maximum and all of those local maximum values of h. So we are going to label this on the graph. When you are stating a maximum or a minimum, you state that as the y value. It's a high or a low point. So as I look across from left to right, the first one that I see is this one right here. That's the bottom of a valley. So we would say that that's a local minimum. And that minimum value is -1. So it reaches a local minimum at -1. Then up here, I reach a high point, the top of a hill. So that is called a local maximum. Again, we list maximums and minimums in terms of their y values. So this ordered pair here is -2, 4. So the y part of that is 4. So it reaches a local maximum at 4. As I move along, I see that again, I reach a local minimum here. That ordered pair that represents that point is 0, -1. So this is a local minimum at -1. As we look over here, I already have that listed. So this is a second local minimum, but the minimum value there is the same. And then we reach one more local maximum, the top of a hill here. That ordered pair is 2, 4. So again, a local maximum at 4 was something that we've already established. So it has 2 local minimums and 2 local maximums. In this case, they happen to be the same high and low value. So moving on then to here, we're trying to do the same thing. So we're going to list the maximum or minimum values of this graph that we see here in example 3. So on the graph, again, I'm going to look from left to right, and I'm looking for the top of hills or the bottom of a valley. So here, I see that I reach a high point. So the graph goes from going up to going down. So that's the top of a hill. So the ordered pair that represents this point is -3, 3. Remember, when we're listing them local maximum or local minimum, we only list the y value. So that's a maximum. It's the top of a hill. So we have a local maximum at 3. Then moving on, I come to this point, which is the bottom of a valley. So anytime that we reach a low point, that is a local minimum. The ordered pair that represents this point is -1, +1, which means that this graph has a local minimum at 1, again, only the y value. And then as I move along, I see one more point where I reach a high point. So that's going to be another local maximum. The ordered pair that is represented here is 2, 4. So that's a local maximum at 4. So you should be able to identify local minimums and local maximums from a graph, and you should know whether it's a maximum or a minimum, and that you only list the y part when you're listing maximum or minimum. Now we are going to look at finding values from a graph. So when you're given a graph, whether you are given the function or not, you should be able to find an x value for a given y value, or find a y value for a given x value. So to do that, it's important that we understand a couple of things here. So if you see something like this up here, f of 2, what that is asking you is, where are you on the graph when x is equal to 2? Remember that graphically speaking, x is our horizontal movement left to right, and y is our vertical movement up and down. So down here in this second statement, f of x equals 2. We know that f of x is interchangeable with y. So when it says that f of x equals 2, that would be the same as saying y equals 2. So what this question is asking you is, where are you on the graph when y is equal to 2? So let's jump down here to example 3. In example 3, we are told that this graph, this picture, is showing us the graph of a function g. We don't have the equation that shows us what function g is, and we don't need to have it to be successful in this problem. And it asks us to find two things. So the first thing it says is find g of 0. So with g of 0, we need to think about that in its normal form, a function could be written as g of x. So really what this is asking you is, where on the graph does x equal 0? So if I look at the graph, I know that if my x value is 0, then I did not move left or right from the origin at all. So we know that when we graph, we start at the origin here. And if x is 0, then that means I did not move to the left or to the right at all. I stayed at the origin, so then I could have only moved up or down. Well, to get to the blue line then, which is our actual graph, I have to be right there. So that point, and this point here, the ordered pair that represents this point would be 0, -1. So when g of 0 is stated, that's when x is equal to 0, we could make this corresponding statement. G of 0 is equal to -1. The translation is, when you substitute 0 in for x, your output value, or your y value, would be -1. So we are also asked on this problem to take a look at g of x equals -3. So for g of x equals -3, it's important for us to remember that f of x or g of x is interchangeable with y. So this problem is really asking, where are you on the graph when when y is equal to -3. So we graph from the origin. The problem here is that we don't know what our x value is. So we don't know how far we moved left or right, but we do know that our y value is -3. And for a y value of -3, we would move down the y-axis 3 units. So from here then, it's my x value I'm trying to find out about. So to get to the line, the blue graph, I can move left or right. Well, to get there, I need to move left 2. So that point there, right here, the coordinates of this point would be -2, -3. So then we can say that g of -2 equals -3. So in other words, if you input -2, you get the output, the y value that they told us, of -3. So let's look at one more example like this. So on this example here, they're really asking us some of the same questions. So let's take a look at these 2 questions that they ask us. So the first thing that we see here in the wording of the problem is g of x equals 0. So like we talked about before, g of x or f of x is interchangeable with y. So this is really saying that y is equal to 0. So if I go over to my coordinate plane, I know that y is 0. So what that tells me is that I did not move up or down at all, because y is our vertical movement, our up or down. So I did not move up or down at all. So how do I get to the line if I'm not going to move up or down? Well, that means that I need to move over here to the left 4 units. So this point here has coordinates -4, 0. Remember, y was supposed to be 0. So that means that we can say that g of -4 equals 0. So for an input value or an x value of -4, we get a y value, an output value of 0. So the other thing that we're asked about here on this one is, what is the value of g of 0? So this is different. G of 0 is different than g of x equals 0. So for g of 0, we know that our normal form for our function would be g of x. So this is really telling us that x is equal to 0. So if I go to the coordinate plane and I have an x value of 0, that means that I'm not going to move left or right at all. If my x value is 0, I'm going to stay at the origin, so no horizontal, no left or right movement. So to get to the blue line, the graph there, I can only move up or down. Well, to get there then, I need to go down 2 units to here. So at this point here, the ordered pair would be 0, -2, which means that we can say that g of 0 is equal to -2. So in other words, for an x value of 0, your y value that you get back out is -2.